Hello everyone. So we are going to start the next concept in fifth unit, that is Hive. We have already completed the pig concept, so we are going to deal with the Hive. So in this we are going to discuss about the introduction to data analysis, and then uh, 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 to make the participants to analysis tools, data analysis tools on top of Hadoop and Hive architecture also. And we will go with the Hive QL also if time permits. So let us go with that. So in this data analysis, already we have discussed as the part of the big concept. So the data, huge amount of data is available that can be taken into the HDFS by using various data ingestion tools. And the data analysis tools are available, MapReduce, Pig, and Hive. So now we are going with the Hive concept. Okay. Hive, what is the Hive? It is the data warehouse concept. It is the Hadoop data warehouse concept, Hive. Okay, so here in this, we can go with that. Actually, it was initially introduced by Facebook to analyze the large amount of data of users, and then it was used, and then it was submitted to the Apache, and it was released as the open source, and it is capable of ETL jobs also, and it is the tool for data summarization, ad hoc queries like our regular SQL only, we can write the queries on the Hive also. Okay, and for the large data sets. And it is providing the SQL-like language that is called the Hive Query Language, HQL, Hive Query Language. And whoever is comfortable with the SQL, they can easily write the queries on the HQL also. That is not the meaning that if you know the SQL, you can understand everything in Hive. No, only for the query writing, it is possible. It is easy to write the queries. That's it. But if you want to handle the data, that is a different case. Okay. So and Hive layers actually it creates a layer on top of the data available, which provides the meta store. Generally we'll call it as the meta store. Okay, so that will maintain the data about data, that is called the metadata. Okay, generally the warehouse, the in the Hive, the data will be available and stores in the specific directory, that is the user, and based on the user and directory we have mentioned, in that there will be the warehouse directory. Okay, it is in our old cluster we have the user, HD user, Hive warehouse, but in our current user Hive warehouse, it is the default path which stores the Hive data in that. Okay, and it is used for managing that, querying the structured data. Structured data can be easily queried easily. Okay, Facebook, yeah, Hive, it was designed in the Facebook only, designed by Facebook, and they have faced so many challenges, like handling the large amount of data to, and also if you want to write if you want to write the programming on the large amount of data, map reduced programming, it is very complex. So what they have done is they introduced a top layer of for the on top of the map reduce. So it is giving an abstract level layer which provides you the SQL-like environment to access the data from the data available in the HDFS. So what we can do is with the Hive. What is that? Well, it is the data warehouse infrastructure, and it defines the SQL-like query, that is called the HQL, Hive Query Language, and it allows the developers to develop the plugins by using the mappers and reducers. They are called the UDFs. We can call it as the UDFs, and now it provides the tools to enable the extract, transform, unload ETL processes. Okay, that is these are the various facilities by the Hive. And some of the use cases is log processing. You can do the log processing, text mining, document indexing, and customer-facing business intelligence. There is the Google Analytics and predictive modeling, hypothesis. All these were possible. Now, what is the Hive? How it works actually? This is the architecture. This is important. So Hive actually we have the HDFS at the bottom, and in the HDFS, on top of the HDFS, there is the map reduce concept, and on top of that, there is a Hive. We will generally install this Hive in one of the machine in the cluster, so that the Hive can access the HDFS and map reduce easily. And now in the Hive, we have it provides the DML and the DDL statements. Actually, in the HDFS, what it will store uh, uh, the raw data only. That is the flat file system. It will be the flat files. So from by using the flat file system, it will have the data in the HDFS. Already we have done with that HDFS, DFS, hyphen put. By using that, we can upload the data that will be in the flat file only. Okay, so that is available, and in the Hive environment, along with the DML and DDL, it is maintaining a separate database. Actually, that what is that database? Means here in the HDFS, the data will not be stored in the form of the table. It is the raw data. Raw data will be stored. And if the data is having some structure in the HDFS, then we can use that data in the form of the table. For that, we need the metadata. Like if you have 1 comma Rama comma 5000 comma A like this. If you have this type of data, we should have the metadata that provides the information about this data. One is the employee number, Rama is the employee name, 5000 is the salary, and A is the department ID. Like this, it should maintain it the metadata. So how this metadata will be maintained? Where it will be maintained? It is not available in the HDFS. So where we can maintain that, that is in the uh, metadata in the Hive. This is also called a meta store. What it stores is it will maintain the table schema which is available in the HDFS. Table schema will be maintained for the data available in the HDFS. And it is also having the partitions and buckets. It will maintain the data in the partitions and buckets. And whenever the DDL statement is accessed, the DDL statement, it will affect the metadata that is in the meta store, and that will connect to the HDFS, and where the particular data is available, that can be connected to the HDFS. Now, whenever you write a query, the query comes into the DML. We can consider that as the DML statement. Actually, it is a DRL, data retrieval language. Of course, we can take that into the DML part. So in the DML, whenever you write one query in the DML, that will be converted into the MapReduce applications. Anyway, the data is available in the HDFS. So the whenever you write one query, the equivalent applications, MapReduce applications will be created, and those applications will access the data available in the HDFS, and they will be retrieving, and this result will be given back to the user interface. Now this is the formal architecture of the Hive. The Hive is having the command line interface. The command line interface will provide the environment to give the queries. The queries will be converted, they have to be converted into the MapReduce applications, and there will be a driver consists of the compiler, optimizer, and executor. Compiler converts the queries into the MapReduce applications, and optimizer will optimize the execution order and execution styles, and executor will execute the programs on top on the Hadoop environment, and it is maintaining the metastore also. And Hive is having the web interface also by using some apps, some by using some tools like Hue. Okay, and JDBC and ODBC, they are also available to connect with the database. So that, and then thrift server will be there. It converts any language commands, they will be converted into the MapReduce, and Hive understandable concepts, and then they will be executed. So this is the Hive architecture. And anyway, the background is the Hadoop only. Hadoop equal to HDFS plus MapReduce. There will be the job tracker, name node, and data node, task tracker. All these will be available. Already we have discussed about all these concepts in the previous sessions, right? So this is overall architecture. Now let us go with a little detail in the Hive architecture, how the query will be executed. This is the user interface. Actually, Hive is having two levels of architecture. This is the Hive environment and this is the Hadoop environment, two levels, two environments. First step, in the first step, user interface, from the user interface, he will provide the query to the driver. The driver will uh, call the compiler to get the plan, and the compiler will communicate with the metastore to get the metadata, and the metastore will provide the metadata, and based on that it will create a plan so that it will send back the plan to the driver, and then driver will send the anyway it is converted, compiled, the compiler will convert the query into the MapReduce applications, and the driver will give the it will give the control to the execution engine anyway, because the plan is also ready, so it will give that to the execution engine. The execution engine will call the job tracker, and the job tracker will call the task trackers to execute the task. They will take the data directly from the HDFS, name node and data nodes, and then the result will be the sent back to the execution engine. You can see that here the result will be sent back to the execution engine, and that result will be given to the driver. From the driver, it will given to the UI, meaning that user interface. So this entire architecture, you can understand that the Hive is providing the a top level layer on top of the Hadoop and Map HDFS and the MapReduce. So it will abstract, it will give you the abstract level of data extraction, data retrieval by using the table structures and by using the queries. Okay, so this is the Hive environment, Hive concept. Okay, architecture. I hope you understand about the Hive architecture. And we have the Hive QL concept. That Hive QL concept can be covered in the next session. Thank you.